Here we continue on with our trig unit, and we're moving on to two-dimensional word problems. So all of today's problems will be in 2 dimensions. We're going to apply all of the trig tools that we've reviewed and you've learned so far, and you hopefully have some recollection of doing them in grade 10 as well, but definitely from the review lessons we've done so far, to solve two-dimensional word problems. The first thing I'm going to give you are some general steps for word problems. Whether or not you choose to copy these down is up to you. But this is generally the process I would follow. The first thing you always should do, and in fact, some of your questions on your test are probably going to say to you, like force you to sketch a diagram and give you a mark for sketching a diagram. But the first thing you should do, sketch a picture with all the information included. Along with that, a couple of subpoints. We're always going to assume anything that's upright and meets the ground or water or anything like that, flat surface, makes an angle of 90 degrees, unless I tell you it's leaning. So if we have a building or we have a cliff, we have a flagpole, a tree, unless I tell you they're leaning and I give you the angle, assume that they meet the ground at 90. Any other scenario, never automatically assume 90. From there, so once you have your sketch done, decide whether to use SOHCAHTOA, sine law, cosine law, 180 degrees in a triangle, Pythagorean theorem, or some combination possibly of all of those. Show all of your work, even if you have no clue what to do, you making the sketch and trying something, that's going to be good for part marks. And never forget for any word problem to conclude with a therefore statement. So like I said, you can pause, copy those down, or make some point form notes to yourself, or we can just move on with example 1. There's only going to be 2 examples, so we're going to keep it relatively short and simple. Our first example, a flagpole stands on top of a 35-meter tall building from a point on the ground some distance away. The angle of elevation to the top of the pole is 38 degrees, and the angle to the bottom of the pole is 27 degrees. Determine the height of the flagpole. So there's a lot of information going on there. Let's make a sketch. Our first thing that you should, if you don't know where to start with your sketch, we have a building, assume it's on the ground. So let's draw the ground. So there's our ground, and we got a building. Sure. And we know that building is 35 meters tall. So we know that that's 35 meters. And let's just put a person on the ground. Okay, there's our person. It says from a point on the ground, some distance away, so we don't know what that distance is, the angle of elevation to the top of the pole is 38. So we don't even have a flagpole yet. So let's put a flagpole on top. Whether you put this in the middle or put this on the edge, it doesn't matter. I'm just going to put it on the edge. Okay, and there is our flag. So it says from a point on the ground, the angle of elevation. Now you have to recall your knowledge of what angle of elevation means. Angle of elevation always comes up off the ground and goes up. So something like that, and angle of elevation goes up off the ground, and it says to the top of the pole, that's 38 degrees. The angle to the bottom of the pole is 27. So we're going to often run into these scenarios where we have 2 triangles in the same question. So I'm going to use a different color. So to the bottom of the pole, it says that it's 27 degrees. So that is 27 degrees. And from our helpful steps previously, anything that meets the ground we're going to assume is 90. We want to determine the height of the flagpole. So our end game is this. We want to know what that height is. So let's come up with maybe a game plan, because I know part of that distance is 35. So maybe part of our game plan, or our general game plan, could be to find out this whole height, and if we subtract 35, right, because there to there is 35 meters, if I subtract that whole distance from 35 from that whole distance, I'll get the height of the flagpole. Now, there are multiple ways to skin a cat here, so to speak. So just because the solution I go over with you does not mean it is the only way to do this. There are definitely different ways. Let's start out, though, with there's a lot going on in that diagram, and there is a lot of visual clutter, ways for us to make mistakes. So what I'm going to do is I'm going to pull out both triangles and draw them separately. So I'm going to draw a big triangle, which would be my tall triangle, and I'm going to keep it color-coded in black. And I know that this right here is 38 degrees. That's all I know from that triangle. And I know this is 90, of course. And then we have a smaller triangle. So I'm going to draw that one. So from there to there, I know that's 90. I know that's 35, right, the height of the building. And I know this is 27 degrees. So we pulled out both our triangles, and we kind of know that our end game is we kind of eventually want to find our overall height. So at some point, I want to find this distance. If it was that easy, if I had enough information just in that big triangle, I could go right to the solution. I don't. And oftentimes with these kind of questions, there's going to be a shared side. And if you think about what that shared side is, the side that both these triangles share is this side down here. I'm just going to call it X. So this bottom is the bottom of both of these triangles. So if I was to find this distance right here, that would also be the distance in my big triangle, and then I'd have enough information to use SOHCAHTOA or sine law or something like that to calculate my overall height. Since these are both, and again, this is not the only way to do this question, but since these are both 90-degree triangles, I could use SOHCAHTOA just to spice it up a little bit and to make sure we have lots of practice. And in the last lesson, I did mention to you that sine law, cosine law work on non-90s. Let's use sine law. I'm not even going to bother writing that little chart that I used before. We're just going to stick with looking at the picture. So I can definitely use sine law because I have a complete ratio. I have an angle with a side across from it. So I'm going to start over here. I'll label this as step number 1. So I want to find x over for sine law, sine. I want to do a bit of a roadblock here though. I don't know what the angle across from x is, but I have an easy way to figure it out. I know that there's 180 degrees in a triangle. So if I subtract 27 and 90, that will give me what's left over, which is 63. So now I can do x over sine 63 equals 35 over sine 27. And again, I'm using sine law just to have some variety here. You could go right to SOHCAHTOA for this. How do I get that sine 63 off the bottom? I cross multiply, x equals 35 sine 63 over sine 27. And again, with our calculator practice, 35 sine 63 divided by sine 27. You should get, now I didn't tell you how many decimal places to round to, so on your test I definitely will say nearest whole number or whatever. Let's just go to 1 decimal place. So you should be looking at 68.69 on your calculator screen with 1 decimal place, 68.7 meters. Okay, so I know that that x is 68.7, and that's the shared side, right? That's 68.7. I just calculated that. So that means this is 68.7 meters. I have a 90-degree triangle. I have two pieces of information that's not the 90 degrees, so I can use SOHCAHTOA. Again, you could use sine law again or cosine law. I'm going to stick to SOHCAHTOA just to change it up. So here's my reference angle. This is the opposite, right? Across from the 90 is the hypotenuse, and right beside it is the adjacent. I want to find out what this is. So I'm looking for the opposite. Hypotenuse gives me nothing, so I'm just going to scratch that out. And I have the adjacent, O and A. So if you were to write this, SOHCAHTOA, O and A, opposite adjacent, only go with TOA. And T stands for tan of the angle you circled, tan 38, equals, it goes in order, right? OA, so opposite over adjacent. I'll just call this, again, you can pick any letter. Let's just call this Y. So Y over 68.7. How do you get that 68.7 off the bottom, right? You want to get Y by itself, cross multiply. 68.7 tan 38 equals Y. Type that into your calculator. 68.7 tan 38. Hit equals, and you should be looking at 53.674, blah, blah, blah. We'll go to one decimal place, 53.7 meters equals Y. And that was step number 2. So we just calculated that this whole distance from the ground to the top of the flagpole was 53.7 meters. And remember, our game plan is to find the height of the pole. Well, if I know the whole distance is 53.7, and I know the building is 35, all I have to do is subtract. So step number 3 here. So my height of my flagpole, we found the entire height, 53.7. I know the height of the building, 35. A quick calculation, 53.7 minus 35 equals 18.7 meters. And do not forget a therefore statement. I'm not going to bother writing it. I'll just do this. You have full creative power here over what you want to do, but some sort of statement, I'm just going to write dot, 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 but some sort of statement like, therefore the height of the flagpole is 18.7 meters. Done. Perfect. This is a good question. I like this question. It has a somewhat of a complex diagram, and it forces you to take a multi-step approach, and you have to figure out a plan. This is an awesome application or inquiry question for that reason. So there's lots of different things. We used interior sum of an angle theorem, we're using the 180 minus, we use sine law, we use SOHCAHTOA, we had to make a plan. Good question here. Just like, and you're going to see some good questions in the 3D lesson, which I guess I just spoiled the next lessons on 3D word problems. Our second and final example. Towns A and B are 112 kilometers apart along a straight river. Town C is across the river. Towns A and C are 72 kilometers apart, and the angle A is 28 degrees. Find the width of the river, and so there's two things we have to find, and the distance between towns B and C. Step 1, make a diagram. So I'll get out some blue here for river. All right, so let's draw a river, straight river. And it says towns A and B are 112 kilometers apart along a straight river. So let's call this town A, and let's call this town B, and we know that that's 112 kilometers. C is somewhere across the river, so over here, and that obviously makes a triangle. And it says towns A and C are 72 kilometers apart. Okay, that's there. The angle at A is 28 degrees. Find the width of the river and the distance between the towns B and C. So we got to find a couple different things here. Now, if you're finding the width of something or the distance, you're always going to take the shortest distance, and the shortest distance, if you remember from grade 10, is always the perpendicular distance. So if I want to find out how wide the river is, I'm going to take the straight line distance, which is the perpendicular distance. That's going to give me, I'll call this W for width. I also need to find the distance between the towns B and C, which that would be small letter a, or you could call it X or any letter that you want. The letters does not matter. So we got two things. Find the width, find the distance between B and C. It does not matter what order you do these in. Let's say we want to find the width first. Let's pull that triangle out. Again, I'm going to redraw it without all the visual clutter. There's W for width. I know that's 28 degrees, and I know that's 72 kilometers. This is a 90-degree triangle, means you could use SOHCAHTOA. I already showed you using sine law last example, so we'll just stick with SOHCAHTOA here. Circle your reference angle, never 90. Label it. There's the opposite. There's the hypotenuse. There's the adjacent. I have to use what I'm looking for plus what was given to me, so bye-bye adjacent. SOHCAHTOA. O and H goes with SO, which is sine of the angle you circle, 28. It goes in order, right? O over H, opposite over hypotenuse. W over 72. Cross multiply, 72 sine 28 equals the width. Using our calculators, 72 sine 28 equals, again, I didn't tell you how many decimal places. We'll go to 133.8 kilometers equals width. We'll ignore that that's an astronomical width for a river. We'll just pretend that that exists. All right, so that was finding the width. Now we need to find, well, I'll use a different color here. I'll use blue. We need to find the distance between C and B. So basically, I'm going to be using this whole triangle. So I know this is 28 degrees. I know that is 72 kilometers. I know that is 112 kilometers. And that's C and B. I need to find the distance between C and B, which means I'm finding distance A. Visually looking at that, we have a scenario where I have two sides and a contained angle, meaning I have two sides plus the angle between them. When I have that scenario, cosine law for side lengths. So A squared equals, I'm not going to bother writing the whole formula. You can if you need to. I'm just going to have the other two sides filled in. It doesn't matter the order. So 112 squared plus 72 squared minus 2 times 112 times 72, and then cos 28. You can type that all in one step. So let's do that. 112 squared plus 72 squared minus 2 times 112 times 72 times cos 28. You should get 3,487.82 blah, 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 blah. Just to show our work. Now we're not going to clear that off our screen. Just to show our work, I'm going to write 3487.8. Remember, that's not distance A, that's A squared. And to get rid of a square root, or to get rid of a squared, you have to square root both sides. So that means A equals, now if I type in root and that answer button and hit equals, you should get 59.1 kilometers. and we've solved both pieces of information we were asked to, the width and the distance. Again, I'm going to give you full creative freedom here. I'm just going to write therefore ... don't forget. Therefore, the width of the river is this, and the distance between towns B and C is this. Perfect, done. Again, a good question. It forces you to make a diagram. It forces you to use a couple of different things. Is this the only way to do this question? Absolutely not. You can make your own game plan, but you do have to use the tools from this unit. So Katoa, 180, sine law, cosine law, Pythagorean theorem, so on and so forth. That's it. Nice, short and sweet. Two-dimensional word problems. Your next lesson is three-dimensional word problems. You can guarantee you're going to see at least one of each on your test. And again, here's some C work listed. Make sure you double check D2L to ensure that I didn't add or subtract any questions from that. That's it. Thanks for listening. Talk soon.